All right, before we go over the fifth and final method of proving triangles congruent, I do want to review the previous four that we've had. All right, so any one of the four, let me know. Proving triangles congruent. 20, any one of the four. Angle, side, angle. That's when I have two angles and a side in between. Another method of proving triangles congruent we have discussed. 16. Excuse me? Okay, I almost had a heart attack there. SSA. All right. Angle, angle, side. That's when the side is not in between. Next up, 24. Nope. How about 9? Side, side, side. And then the final one we have discussed. What do you got? 7? If you got to look back, you got to look back. Side, angle, side when the angle is in between. Everyone all good? All right. I wait for this one to last because it really doesn't fit the model of sides and angles. It is called HL. All right, HL. Short for hypotenuse leg. Okay, hypotenuse leg. And I wait for it last because it can only be used in a certain instance. Can't be used anytime you want. All right, I don't know if you want to circle this, star it. Hypotenuse leg is only reserved for right triangles. That is it. Right triangles only. Now, does that mean every time I see two right triangles, it equals HL? No! No! Why are those two triangles congruent? Oh boy, we're in deeper trouble than I thought. Side angle, side? Where's the other angle? Yeah, I don't know either. Side angle, side, right? Everyone agrees? Side angle, side. So I don't want you to think, oh, I see right triangle, that always equals HL. No, it does not. No, it does not. Next thing I want to go over. Where is the hypotenuse located on a right triangle? That's as best I'm going to do. So I have a right triangle because you have to stop saying it's the longest side. Since when do you ever have lengths on the sides of a proof? Never. So can somebody give me a direction to go if I give you a right triangle where the hypotenuse will always be located? Always. Talk to me here. Where would the hypotenuse always be located? Because there's not going to be any length, so don't give me the longest side. 23, where can I go? Okay. That's fine. How about the side across from the right angle? All right, that's always the hypotenuse. And what are the other two sides called? Those are the legs. Yep. So as long as, ready? As long as a pair of hypotenuses, where do I go with that one? Do I have any English freaks here? Hypotenuses. I always have issues with this every year. If they're congruent, it's kind of like rhinoceros. What do you do there? Rhinos. Thank you, Violet. Rhinos. Hypos. The two hypos. That just doesn't sound right. That sounds dirty. I don't know. Hypos. All right. All right. And a pair of legs. We good? Okay. And also, some of you guys that may be thinking about this, you are correct that I thought you said SSA was never going to be a way. Okay, you're right, but it's only a way for right triangles. And we're not writing SSA. We're writing HL. Okay, so that's why I say never write it down on your paper. All right, let's use HL here. I'll give you a second. Mark your diagram with the givens on this first one. Angle ABC is a right angle. First, I want to show why it's HL and then what to put in the proof. And feel free to mark anything else you want on your own, other than my givens. What else could I still mark on my diagram that was not given, but I know is 100% true? 4? Which one? CB, yep. CB is reflexive. All right, let's talk. Why is this HL and not anything else? Because again, don't think right angles equals HL. Doesn't happen. Here you go. Ready? Look at what I have. 2 sides and an angle. Is that angle in between the 2 sides? Is that right angle in between my 2 sides? No, so it's not side angle side. But what is AC in this diagram? That's my hypotenuse, and what's CB? Leg. So does everybody see HL in action before we do this proof? We all good? All right. You guys made some markings on your diagram, but it did not get into my proof, so I'm going to ask somebody first, what needs to go in here? That's on the diagram, but not in the proof yet. 13, what's got to go in here? C what? CB, thank you. CB congruent to CB. That is reflexive. Yeah. I'm just going to let you guys take over, and then I'll correct it from there. All right, because all proofs are pretty special. 20 nothing. How about 22? What do you think else has to go in this proof? Because they're right angles? Okay, I'm going to stop there. All right, I'm glad you did that, Dylan. He said show the right angles are congruent, all right angles are congruent. That's what we've usually been doing. You do not have to do that in an HL proof. Here's why. What's the H stand for? And what's the L? Did you mention any angles? No. All you need to tell me is that they are right angles. Okay, so let's say you did write that they're congruent. Okay, that's a true step. It's extra. I'll never mark it wrong. Okay, so if you forgot that, that's fine. If you wrote down that the right angles are congruent, it's a step that's not needed, but it's correct, so I'll never mark it wrong. So that does not need to go in any HL proof. What does have to go in, and this is in your up top on your notes, is that if you plan on using HL, you must say that you have what type of triangles? Right triangles. All right, so before we say these triangles are congruent, you need to tell me that they're actually right triangles first. So triangle ABC and triangle DCB are right triangles. Only in HL proofs do you need to say they're right triangles. Now let's talk about the reason. What in the diagram says they're right triangles? Okay, so we're going to write right triangles have right angles. That's why you need to say you have right angles. Okay, so does everyone see what's needed up there before I actually say they're congruent? You need right angles. Don't need them congruent, but you need them. And then you need to tell me you have right triangles. All right, everything's good now. Now we can say they're congruent by HL. So triangle ABC is congruent to triangle DCB HL. So does everyone see what, because the proofs are going to get progressively harder here, the next two. Yep.
What's it called? One like you know, like the third angle is one.
Yep.
If you have the 2 sides, when you just say that it's the 2 sides, you can do the third one.
That's never been a thing. The third sides theorem?
Yeah.
No, nah, bro. Nah. Only angles. Only works for angles. All right, no such thing as the third sides theorem. Everybody good? Ready to get a little tougher now? All right, a little tougher. All right, couple reasons this is a little tougher. One of the givens is a little unique, a little different than what we're used to, but I think we can handle it. And the proof statement doesn't say proof triangles. All right, so let's get our diagram marked. CD is congruent to EA. Got it. All right, going to turn it over to you guys now. AD is the perpendicular bisector of CE. We struggled with this a little on the quiz. What is being cut in half? That's all I want to know. What is being cut in half? Because it's not both of them. Oh, 16. What line segment is being cut in half? CE. So I'm going to mark CB congruent to BE. Not the other pair, just those two. And it says this perpendicular business too. Perpendicular lines form what? Yeah. So I should put right angles there as well. All right, let's stop. Go to the proof statement. We did this last week. Anytime you're going to prove a pair of segments congruent, you probably want to prove what first? The triangles, because I know at the end of this proof I'm going to write CPCTC. All right, but not unless the triangles are congruent. So let's go to the triangles. Are the right angles in between the sides? Are they? Nope. But they are right triangles. What are these two acting as? The hypotenuse, and these two are the legs. Do you see HL in action? Okay. So I'm going to turn it over to you guys, and you guys got to tell me what still needs proof before I get to HL. $28. $11. What still needs to be put in here? And what's going to be your reason? Do you have right angles yet? On my diagram I do, but not in the proof yet, right? So instead of saying the right triangles first, let's say angle. There you go. Angle ABE and angle CBD are right angles. Got a reason for me there, Charlotte? Yep, perfect. There we go. All right, turn it over to you guys still. What still needs to go in my proof? 20, what still needs to go in here? Good. Why is that true, Violet? Yep. And if you want to put perpendicular bisector, still good too. Okay, we're moving. Still not ready to say HL yet. 4, what still needs to go in there before I say HL? Okay, you can put that in there. That's fine. That's true. But because it's HL, I don't need it, remember? I don't need to say the right angles are congruent. It's still true, though, and wouldn't mark it off. If you want to put that in step 4, that's fine. Any HL proof doesn't involve angles, so I don't need to say they're congruent. All right, still going. What else needs to be put in there? 22? Yep. Triangle ABE and triangle CBD are right triangles. Do not worry. Do not worry in this step if sides and angles match up. I don't care. All right, it's the congruent statement I care if sides and angles match up. I don't care in this one right here if they do or not. Why is that true, Dylan? Yep. All right, now we're good. Now we can say we got everything we need to say they're congruent, and I'll let you guys write your own statement, and I'll ask somebody for theirs. 20, want to share your congruent statement?
Triangle ABE is congruent to triangle. Oh wait, no, that's not right. Oh wait, C.
So your second triangle is DBC?
Yes. And that's HL.
So once the triangles are congruent, any pair of corresponding parts are congruent, including AB and BD. And that, if you're going to use it, it's got to be in the correct order. Or you could write out corresponding parts and congruent triangles are congruent. All right, we're going to skip 3 because at the end of class, you're going to do that with your group, and we're going to go to number 4, the toughest one we're going to do today, number 4. So skip over 3, don't touch it. You'll have plenty of time to do it in your group. Let's go to number 4. Go ahead, mark your diagram, givens, you guys know the deal, because that proof statement's a little different than anything we've ever seen this year. All right. I'll give you guys another couple seconds here so we can talk about the proof statement. Little different than before. How am I going to do that? So our job is to prove AB bisects DAC. All right, ready? If that was true, name the 2 angles that would be congruent then. If that's a true statement that AB bisects DAC, then you would know at least what 2 angles should be congruent if that's a true statement. 29? All right, so if true, angle DAB would be congruent to BAC. Everyone agree? Okay, so prove those 2 angles are congruent then. That's your job. Prove those. If you can prove to me those 2 angles are in fact congruent, hey, I got myself a bisector. Okay, so show me DAB and BAC are in congruent angles. But they're not going to be congruent unless I prove what first? The triangle's congruent. Yep. What else you want to put on the diagram? Let's focus on the triangles first. What else you want to put on the diagram? 4, what else can I put on the diagram? AB congruent to itself. I'll just throw it right in the proof now so we don't forget. Is that right angle in between the 2 sides? Nope. What's AB acting as in the right triangles? That's the hypotenuse. There's only one there. And then how DB and BC? Legs. All right. You got the reflexive side for me. You got the legs for me. What else still needs to go in here before the triangles are congruent? Let's roll 29.
Triangle DAB and triangle CAB are right angles, and right triangles have right angles. I meant they are right triangles.
So you want to say they're right triangles because they have right angles.
Yeah.
But I do not have any right angles other than in my diagram.
DBA and BCA.
That, okay, yep. Get in this habit. Got to say I have angle ADB and angle ACB are right angles. What's going to be my reason here, Logan? Not off the hook yet.
Perpendicular from right
Yep. Okay, now that I have right angles, what can you tell me? 21, what else here?
That the triangle BCA and triangle BDA are right triangles.
Yep. Why?
Right angles from right triangles.
Just because I have a right angle doesn't mean I have a right triangle.
Right triangles have right angles.
There we go. I got the right angles, got the right triangles, got the H, got the L. I think we're good. I just need a congruent statement from somebody in the correct order. 25. Yep. 21.
Triangle BCA is congruent to triangle BDA.
By which one of the 5 methods? Yep. And then again, why did I want the triangle? So now what is true? Not the bisector part yet. That's not true yet, but the pair of angles are congruent. DAB and BAC. And they're congruent because of CPCTC, yes. And then, okay, hey, look, those 2 angles are now congruent, so AB has to bisect DAC. We just need to talk about what's a reason. I don't want definition of a bisector. That's like me saying, hey guys, I see you're sitting in a chair. How do you know you're sitting in a chair? Yep, definition of a chair. It tells me nothing, all right, about what a chair is and how you know you're sitting in one. So how do I know AB bisects DAC? Just talk to me. Forget about a word-for-word reason right here. How do I know AB, in fact, is bisecting DAC based on everything we've done? Why is AB a bisector? Just talk to me. 29.
Because they're congruent angles.
What are congruent angles?
The DAC, the 2 ones on the side of the line.
Do they have a name?
DAB and CAB.
That's exactly what I'm going to put. I know that AB bisects because I just showed that DAB is congruent to BAC. That tells me that it's being bisected. Okay? Okay. You and your group, and what I mean by you and your group, I am not coming over to check individual proofs. When you and your group have agreed these are the steps we need to prove angle 1 congruent to angle 2, then you call me over. Dylan, you can pick whichever one. The one behind you or the one up here. All right? Please. You don't get an option, Eric. You're working with your group. Yes.